Splines suck, but they're also kind of great because they allow us to do cool things, like taking the staircase and making it into a loop. This is something I can imagine as an entryway to a building or a chamber, but the problem is this can't be done with a simple spline. If you've worked with splines for only a short amount of time, you may have come across several issues working with meshes. Possibly the biggest is the fact that splines don't inherently work right when you try to make vertical loops, or if your spline bends are too sharp. Meshes will twist, deform, or just flip upside down. And if you wanted to change a mesh after aligning the spline, you could be back to square one with fiddling with its orientation. But we're going to be going through a couple fixes for each of these problems. We'll be working with the blueprint from part 1, so if you haven't seen that already, you can check that out, but I'll be giving a quick summary in a moment. All it allowed us to do was add and space meshes out across the spline line, and today I'm going to be showing you how to make meshes bend with the spline line, and offering a method to be able to adjust the meshes to blend seamlessly from one to another regardless of any twists or bends that we want to put on our spline. So, let's get into it. This is the blueprint that we made in the last video. Primarily, we just add a spline mesh component, a static mesh, and set the forward axis in the construction script of our blueprint. Then, depending on the forward axis that we choose, we use a bounding box for our mesh to be able to get the length of its X, Y, and Z dimensions, and set that to be the mesh length. Now, in the last video, we have the mesh length plus the spacing that we wanted to add, if any, manually. We're not going to be using that. Instead, we're just going to be using the mesh length because we want to have our meshes line up flush next to each other. We're also not going to be using this transform, but we are still going to be looping through the section here and using these spline mesh components. So very simply, we can just copy everything from our loop and bring it down here. I'm going to drag this back and I'm going to set a branch because the top part of this, what we did last time, is going to revolve around spacing our meshes, and this time we don't want to be doing that. I'm going to connect the pins for true and false here, promote this to a variable, and name the variable space meshes. Now we can compile and save. We're going to also take our section length, remove it, and add in our mesh length instead. And instead of using the transform for our add spline mesh component, we have another node that we can use. We can drag off of the return value of our spline mesh component. And we are going to set, start, and end. Just organize that a bit. And now our start position and start tangent is going to be the same as our end position and end tangent. At the index of our spline, it's just the start is going to be the index and the end is going to be the index plus 1. So we can drag in our spline, and our starting position is going to be our location at distance along spline, which luckily we have a node for that. So get location at distance along spline. And we are also going to get tangent at distance along spline. The distance is going to be our index multiplied by our mesh length. So connect them to the distance here. And we can connect our distance to the start position. But for our tangent, we need to clamp the value so then it doesn't look like weird geometry. So we're going to clamp the vector size. The minimum is going to be 0, and we can copy our mesh length to be our max. And then we can connect the return value to our start tangent. Then I'm going to drag this index back a little bit, highlight all of this, right click, and collapse it to a function. And I'm going to call it get location and tangent. Then we can drag it up and connect it for our start and end. And I'm going to get these out of the way because we're just going to copy it and paste it. And we just need to add one to our index. Connect our return values here and here. Compile it, save it. And now we can take a look and see how this looks. So here I have a couple spline meshes that I've just written out. We're just going to use this first one. I'm going to add a spline mesh to it. And I'm going to just use the pipe mesh that I was using in the last video. So shape pipe that comes with the starter content. And we need to change our forward axis to Y. And as this is spacing our meshes, we are able to see that it does not follow this. So we have to go back, and I forgot, we want to make sure that space meshes. Click on the eye so then we can toggle between our states. So now I am going to uncheck this, and now you can see everything is following the line. It is bending the meshes to be able to have a contour. Now, one thing that happens is that if we try to drag a line directly up, you will see that there is this break that happens. And if we try to rotate away from it, it still is going to be a constant issue. The way that we fix that is by defining an up direction. So we go back to our blueprint, and after our start and end, we're just going to drag off the return value for our mesh component one more time, or spline component rather, and we are going to set up the IR, set spline up direction. Now, to set our up direction, we're going to drag off of our spline, and we are going to get up vector and distance along spline. Connect that to the return value, and then you can compile it. If you set the spline up direction with a connection to the target and or a connection to our in-spline up direction, and then try to compile it while either of those two are blank, you will crash Unreal Engine, so don't do that. Now, to calculate the distance of our up vector, we want to get the midpoint of each section. So we are going to get the start, which is just the index multiplied by our mesh length. And then we are going to get the end. I'm actually just going to comment this. And our end is going to be just this result and the mesh length. However, if we are only partially using a mesh and not fully down, we may not be able to have a entirely full mesh length. So instead, what we can do is use the distance of the spline as an endpoint as well. Let's drag in our spline and get length. And we're going to select the float. We're going to connect A and B as so. And our Boolean is going to be if our mesh length is less than the total distance, we'll pick that. And we'll comment this. And we'll call it start point and end point. And then we want to take our start point and subtract it. And then divide by 2. And then we want to add our and point back. And that will be our distance. We're going to be reusing some of this, so before I collapse it to anything else, so we compile it, save it, and then we can go back. And what that allows us to do is when we rotate these points, we're able to change the up vector. So now if we move this, we see that we're doing a little bit better. And if we don't want to have it be so harsh, we can fool around with this. Obviously, it would be better just to have wider meshes. They're spaced across as such. And make sure you also fix the rotation of the points that come before and after it. I'm also going to be adding a debugging section to this, just so then we can see. I'm going to add a branch and promote it to a variable. And I want this to show the up vector. I'm just going to call it show up. And if it's true, you're going to add an arrow component. And we want to set this to be on the spline points themselves. We're going to drag in our spline, and we want to get location at spline point. And we want to get rotation at spline point as well. The index is just going to be whatever index we're currently on. And we can connect the location to our transform location. If we just connect this into our rotation, it's going to just face the arrows pointing down the spline. So we can combine rotators. Connect that to B and set that in, and we can just put 90 in the Y value. And arrows are kind of small, so I want to make sure that they are kind of big, so I'm going to just change the scale to 155. Compile it and save it, and now you can see where the up vector actually is. So you can see as we start twisting the spline, it changes the up vectors. Now this looks all fine. However, notice that if we were to change this pipe mesh to something like a cube, we're just going to use SM cube, it looks like this, which is not exactly what we want. Now, a way of solving this, rather than getting the up direction from the midpoint of each mesh, we can get the midpoint between each spline point and then lerp each mesh between it. So I'm going to just grant myself a little bit more space here. And we need to get our input key. The input key is actually the float value of our spline point. And we're going to make use of some of the math that we have down here. We're going to take our start point and we are going to add it to our endpoint. I apologize for how messy this is already. And then we can divide this by 2. And then we will get our spline component in. And then we will get input key at distance along spline. And connect this to the distance. Then we promote this return value to a variable. Connect it and call it input key. we are going to manually have to enter in the input keys that we want to evaluate. So we can do that by adding a new variable of type integer, and we're going to call it up vectors. And then up on the top right here where we have this drop down, we're going to change it to a map and change the second integer to a vector. Now we just make a map of vectors. With our vector, we can drag off and set find like we do in an array. And we're going to copy that twice. And so we want to take our input key and we want to get the ceiling, just CEIL. And then we also want to get the floor. So whatever location we are, the closest input key above us and below us, we are going to lerp the vectors. And the alpha is going to be a fraction of our input key. We get input key and type in fraction. And we're going to copy our set spline up direction and connect this to the up direction. And we're going to connect the target pin. And we're going to use these return values and use that to determine if we are going to be using this method or the previous one. We can drag off one of them and get and. Connect the other pin. And we're going to put a branch right here, right after we declare our input key. And if it's false, we'll do what we just did before. And if it's true, we'll be using our new method. And connect that branch there. And drag this down as best as I can. And I still want to see the arrow component, so I'm going to connect that to our debug. Compile it, save it, and let's see how to use it. So first off, if you look really closely, you can see that the mesh that we're using is not centered on the spline line. That is something that we need to do. So I'm going to drag in our SM cube here, and I'm going to go into the modeling section, click on Xform and edit pivot, and I'm just going to click center. Now keep in mind this warning. If you don't want to be doing this with the only mesh that you have, you can copy it, or you can use a different mesh. But for now, I'm just going to be going through and setting that to be center. Change it back to section. You can see, while it's still not conforming correctly, it at least is on the spline line. So now we get back to our up vectors. We start up here at input key 0, 0, which means that that's our first spline point, followed by 1, and followed by 2. So just to demonstrate how to make this look flush with the first 3 spline points, click the plus here, and when you click plus again, you'll see this error coming up because it's trying to add 0 by default, so you need to change that to 2, add it again, change it to 1, add it again. And you can see the vectors that we have all default to 0, 0, 0, which does affect the shape. And it could take a little bit of trial and error to see how you want to have this be aligned. You want to change all of them to the same thing. It's likely going to work kind of okay. Unless you get bends like this, then it may be a little bit more difficult. And if you want to have twists, it's going to take a lot of fooling around with. But we only have to do that for the sections that we want to be able to manually enter. If we wanted everything to look this flush, then we would have to add every spline point that is being an issue, which at least looks to be that way up until spline point 5. So I'm going to 5, 4, and 3, and add 0 again. And so to change 0 to our y, and let's try all of them being y. Okay, that is making it much more flush. If you wanted to have it follow and twist around, you can mess with these values. Get 3 rather than having 3 by default. Looks to be using the y-axis as its up direction. Putting 1 doesn't do anything. Putting a z does mess things up a bit, as does x. But you can subtly change these points. They don't have to be 1 or 0. They do increase with magnitude. You can see I'm typing 0.1, adding it every time. And even adding over that will still affect it. It is a bit of a hacky method, but it is the only way that I have found to be able to have meshes such as this. If you wanted to have something more or less blocky, again, that's going to be dependent on how you build your mesh in the first place. For example, if I wanted to get rid of the harshness of this corner, I can click on this node and you can see that it's not bent correctly. We can adjust the pivot point so that it is a bit more curved, and we can do so with the same below on our spline line. But you can see as we are starting to move it around, we are breaking this a little bit. And you'll notice that if we're using this method and we want to rotate our up vectors, it is able to move this one here at 6, which is our last point. But if we were to try to do that at 0, which we did not add a spline point 4, you'll find that everything is sort of overridden. Which is good, because if you wanted to have rotations on the spline without changing how the spline actually looks, this is a method of which to do so.
Thank you for watching. I hope you found this video informative. If you want to see what we'll be doing with the spline blueprint next, you should subscribe. And if you just fast forward to the outro because you're impatient, you could just download this blueprint for free from my Patreon. The link is in the description. And as always, if you like the video or have any questions, let me know by leaving a like and a comment. Thank you.